So this question is like very important. This is one among the very crucial questions. So first of all, what is the given in the question? We have to find the longest nice substring here, and what's the definition of this? The definition of nice substring means that substring, if that substring contains any characters, let's say a, so it must contain its uppercase character, means capital A is also included in this substring. Similarly, let's say if it contains capital B, so it must contains a small b also. So there's like a and a b b. So here the what are the like unique characters here? There's only a and b used, and since if a are used, so it's small and it's capital, both should be used. But when we see for the b, so here capital B is include in this, but small b doesn't include this. So it means it is not a nice substring whole. So we have to like find only of the substring of this. So like this is the substring that contains only a heads element, and there's a still a validation of this definition of the nice. That's why, so this is only the longest possible nice substring here. So we have to find like for the longest. So we have to given in this test case, there's the whole string given here, and we have to find what is the longest substring here, which is a nice. And we, as I already say, what is the definition of nice? If we see, like if we start off the nice substring here from here, so we have like first we have to see. So okay, in this, if we have to assume all, first of all, it is clearly the answer, or we can say the resultant substring should contain at least its size as greater than 1, because if its size is equal to 1, so that's mean if there's only one possible format of any character is allowed. That's like, let's say if there is capital, so for taking the small letter also, so it must contain at least two characters, at least. So that's why this substring is not able. But let's say we have, if I have to expand it to this, but here we have to find, or we have to seek small y and capital A, but it doesn't. Like if we have to expand it to this z, okay, now we have to all now our search is for capital Z. Now if we have expanded here again, we have to search for the capital versions of A and capital versions of Z and small version of A. Now expand it, okay. So now we have seen we have to meet capital version of A. Now what are remaining? So we have to seek for the capital version of Z and smaller version of Y. Okay, now expand it, let's try it. So again here, not our requirements not meet. Now okay, then expand again. So we reach till at the end of this whole string, and here our requirements of y and a is complete, but z is remaining isolated. And since we have to find the substring and it must be continuous, so we don't have to take this part or this part as our array. So our substring here, so that means we have to find, so this is the resultant longest substring possible here, which is condition, like means both the smallest and largest versions of each character should be contained here. So only this is the possible here. So similarly for this whole string we can take as a whole substring here, because here both versions of b is found here. Now if I see, I already tell you the any of the substring with size of 1 is not possible, because here only one version of each character is one version of the character is found, like smaller, but we have to seek, we have to try to go for the upper version of the C, but not it is, since only of the length one, so here is not found. So that's why we have to eliminate this part. So that's why we have to result, so in this case we have to result only empty substring here. Okay, now see, we see one thing here, there's the size of the array. Since it is very small, so it would be accepted for the brute force here. Like first of all, what is the brute force here? Like it's simply, the first thing that comes to my mind is simply I have to generate all of the substrings, and you know very well how to generate substrings. So like we simply use the two loops here, I loops for the outer loop for indexing of the I, and we continue of the j indexing that after I, and it goes to ln, and for each index we have to just check out the what is the resultant substring here, and corresponding for each substring we have to simply check whether it is valid or not. And how we can check? So it also takes of n for checking, and for the creating it takes of n square. So means resultantly for the brute force it takes basically of n cube time complexity for the brute force. So like you see here, so I already write the code here for saving our time, because this videos goes to till long. So because there should be there's a time required for the explaining the most optimal way, because that is the a very typical approach, or like very tricky part here. So first of all go let's leave it. First of all, let's go for the brute force. So here's our main function defined here. I simply initialize our minus our size here, and let's say this is my length, because I have to calculate, I have to how to judge whether my current substring is the maximum among all of the previous substrings there. So that's why I have to judging for this, or I have to keep previously stored length. So that's why I use our maxi. We can initialize it into main or zero, it doesn't take much anything. Okay, so now if here is what is our answer. So it is basically our resultant answer here. So first of all, brute force, we have to simply I 0 to n, this loop goes from 0 to n, and for the each of I have to reset our the string, or I can say I have to create one substring here. I can create one string here. Now the inner loop is j goes from I to n, and you can simply let m plus equal to s of j, and we have to check each string whether if this I can use the check function here, and we have to define it in the upper of the function, and I have to say check of this temp means this temp, I can say the current substring here. So I have to check this if it is true, and if its size is greater than max, so we can update our max size, and simply our final answer, or we can say the answer is become the temp answer. Okay, and at the end we have to simply return our answer. And how to check this function, how to define this check function? So it's simply using bool is check of, and we have to pass string temp. There's no required to pass and reference, because we have to don't call it again and again. So how we let's say I have to pass, let's say I have to pass one string here. Let's say I have to pass here, there's a there's a capital A. Why is not okay? There's a B, then capital B, and there's a C. Okay, so this is my substring here. Okay, so now for the storing of the small characters, we have to make this small vector, and similarly for the large vector, large characters, I have to make large vectors here. Okay, so there's since there contains only characters which is of the 0 to 26, that's why there's a size initialized with 26 size small vectors and large vectors here. Now I have to traverse for the whole of the temp string there, I 0 to n. I have to check whether if my temp contains a small characters, means greater than a, less than a. So if my temp string contains a small character, so I have simply update my small of temp of y minus a, because this is this corresponds to the index. So this become our index, so I have to simply update that index of my small vector. Similarly, if my temp character contains capital characters, so I have to simply update our large vector index here. Okay, so after traversing whole, I have to simply store all of my small characters and large characters. So now finally if I have to traverse I is equal to 0 to 26, I have to judge if I have to find my small version of any character, and at the same time I'm not able to find the large version of it, means it is invalid. So I have to simply return false, means this string is not a valid. Okay, or we can say this string is not a nice. So and similarly, for if I have to find a smaller version of this character but not able to find the larger version, so here also I have to return false. And if the if these both conditions are not met, means we have to reach at the end of the array, we have to check for the a0 from a to z and see all of the version are correct, means this string is a nice. So in this condition we have to return the true here. So So that's the definition of the check function. So I think this is a like a understable, and as I already explained, its time complexity. So since this loop goes from this end to this end, because for generating, so this takes of n square, and for each time with checking function, like we have to pass here, like simply we can't, like we already said, uh, for each time of check function I have to simply run a loop for n, so that's why it takes already of n, so this whole takes of n cube, and the space complexity is simply of 1 because I can't use any type of extra space here. So that's the brute force. But now since the interviews is not with this brute force, so we have to go for the optimal part here. So like how to try it. So like in my previous videos I already tell you one trick here. Whenever we have to ask about the substrings or subarrays, so like if we have to go for the optimal side, so we have to eliminate that generating all of the substrings here. We have to, we like first intuition that comes is like since what's the property or what's the special between this string or this array is like they are continuous. So like first intuition is goes to use the two pointer, or I can say use the window means continuous window, so it means we have to use sliding window here. But there's also some conditions also need to be met for using that subarray, using sliding window. Like sliding window is only applicable in the case if we have like any kind of monotonicity, predictable monotonicity, or I can say like I have such operations in a question given in which like it hints us to like move it or expanding in a one direction or shrink in a one direction, or I can say it in the question if it is kind of given it, we have to find the longest substring till this array or this nature is like this monotonic nature is readable or predictable reason. So like if like let's say if I have to implement a sliding window here, let's say I have to use this as a window, but I know this is, let's say I know this is not a nice substring, but like we don't know after expanding it, this window, can it be substring, can it become nice, or after shrinking can it become not nice. So like we don't know any nature of this, so that's why I don't use a sliding window here. So like we should go for the another approach, or should go for the another method. So we see what there's a very tricky part here. Since here we have given like it is a substring, so simply first thing is clear, like it must be contiguous here. Okay, so let's say if I assume, if I have to go for the checking whether it is not, or whether it is a substring or not. Okay, so like I have to start, let's say I have to start from this. Okay, so I have to assume if what is the condition here, whether it is become valid, or whether whether like it can create a problem for the generating nice or not. So like let's see if I have to traverse for the substring, so we see one thing here, like when we are coming to this index at I equal to 2, so we see this z create a problem. So if it create a problem, so what it means, it means we can't take this whole as a sub, as a nice subarray, or we can say nice substring here. So what it means, I, so we can assume either, so it is guaranteed like either our answers lies in the right of this z, or we can say it answer our answer is lies at the left of its z. So what it means, if let's say if this z is creating a problem, so either of the our the longest nice subarray lies at the right side, or we can say it lies at the left side. And like let's say I can assume if it rests at the right side, so we have to like also so we have to now check for the right side, and like simply split this part, this is split this part. Why we do splitting here, because we see one thing, like if any character is causing invalid nature, so it means the resultant answer can be caused at a right, or can be lie on the left side or right side. So what we do here, simply splitting here in the left and right, and now checking for the answer for the left part, and simply goes to left and simply, so this simply becomes a like a recursion array. So what we I have to, if I have to just to memorize this, just to wrap up this whole part, so we, what we do simply here, we simply divide and divide it. So we can say it divide and conquer. I also explain it by the recursion, or I can explain it by the like dry run here. So here, see here, let's say we have a simple array given here. This is a C and a T, C, A, B and B. So now like, so okay, so if I have to judge here, first of all I what we do here, simply we store the all of the occurrences of the last lowercase version and capital version. So let's say if I have any first of all, what we use for the unique recurrence, or we can say storing for the unique recurrence of the each of character. So what we simply use here, we use a simply unordered set here. So now store all of the part. What is a uniquely stored here? So we can simply store C there, A there, T there, capital C there, a small b and the capital B. Okay, so we simply store all of the unique characters here. Okay, so this is our unordered set here. Okay, now we check for this. Let's say if I have to go for the this C, small c, can we see, now we see, is capital C is included in our unordered set? Yeah, it is unordered set, so it means it doesn't create any problem. Okay, now go for the small a. So is it capital version here, capital version included in our unordered set? It doesn't. It means it creates a problem. So if it creates our problem, so what it means, either our answer reside on this part or either our answer reside on this part. So it means we have to just split in this two array, so like in the left side or right side. So I can say what is in reside in the left part, so there's only string C, and what is on right, so there's a C capital T A, and there's the capital B. Okay, so okay, so simply what we have to do operation for the this whole string. Now we have to do operation for this left part and simply for this right part. So now we check for this C. So like when we have to come for this string, so we also we again we have to make a unordered set here. And what is the unique character is, so here only alone character is a small c. Okay, now when we traverse from here, uh, we see one thing here, whether its capital version is in subordered set. So we see no, it is only small c, means it creates a problem. So if any character we have to found is creating a problem, means now this is time comes on to split it. Okay, so okay, so divide is splitting it. Now what is the in left part, so there's an empty array. So like we simply denoted by empty array. Similarly on the what is on right side of this C, so here is nothing, so this is also empty array. And like now we reach at the empty part here, and we can say one thing, okay, well, first of all, I'm using this code here. Okay, see this is our code here. I have to copy to this editor. Why I'm not able to? Okay, so there's a okay, so this is the divide conquer. First of all, I use the base case here, as I told, as I'm already talked to you. Like if I have to reach n less than 2, so I simply return empty array. So actually there's no need to go to the left part or right part to here. Like we see one thing here, if there's only one character remaining here, means we are not able, means it can't be answered, so we simply return the empty part here. So empty part means we simply return empty string here. So there's the empty string here, so there's empty string, so there's no, actually no need to go to the left part, right part. Okay, so we have to complete this part. Now goes to right part. Now check for this string. So first of all, make its unordered set here. Okay, so now store all of the unique part. So there's a capital T, there's a capital C, there's a small b a, there's a small b, and there's a capital B here. Okay, so like I have to store simply all of the unique occurrence of each character. Now I have to simply traverse. Now I go for the capital T. Whether it, and I have to check whether its a small version is in our ordered unordered set. So we see this is not included in our ordered set, means it creating problem. So it means we have this time comes for the splitting. So like simply split it. What is in its left side? There's nothing. So it means it is simply is empty here. What is in right part? Okay, so there's a what is in right part. So there's what is C, there's A, then B, then capital B. Okay, in the left part there's an empty array. Okay, so like now simply goes to the left part, and we see simply if there is an empty array means how is less than equal to 2. So what we simply return here, we simply return here is our empty array here. Empty sub I like mistakenly say array. This is nothing but string here. Now okay, now go for the right side. Now checking for this string. So first of all made it unordered set here, and now store all of the characters, unique characters here. So there is a capital C, small a, capital B, and small b, capital B. Now check for this. Now traverse first of all, like when we say for this capital C, is it small c present here? No, it is not present. Means we finding like a problem creating. So time to split here. Okay, so what is in its left? So there is nothing. So that's why this is an empty string. What is in right? So right we see one thing, A, B, and capital B. Okay, okay. So like how to expand this window. uh, how to do this? Wait a second. I i don't think it is expanding here. Okay, like we see one thing here. Okay, if I like we simply return here the size is 0, means this is we reach a base case here, so it simply return the empty substring here. Now go to the right side, so make its unordered set here. So what it contains, this small b, this is small a, small b, and capital B. Now check for the small a. So we see whether its capital version is included in another set. So it doesn't, means it creating a problem. So now time to splitting again. So what is in its left side? There's nothing but empty, so that's why empty. What is in its right? Because there's two characters here. There's a small b and there's a capital B. Okay, okay. Now similarly again, if we have to go for the left side, it is empty, means it returned empty here. Okay, so no need to go again and again, as I explained it on the previous steps. Now go to the right side now, and again make its unordered set and store the small occurrence and the capital occurrence of the B. Now check for the B. If you have to say about B, so is its capital version is in set? Yeah, it's present. Okay, now go for the this capital B, whether its a small version is present. Yeah, it is present. It means we check see, so if we have to see this, we have to simply continue this. Okay, if we find this B, it means there's nothing kind of string which creates a problem, means we simply return this capital B here. Now we check for this, from left it check empty string, and from the return from the right it gets a small b and capital B, means two character length here, there's an empty character length here. And we see one thing, if any of the size length, any of the side length is more, means we have to return that side, that is string here. So it means the right string means small b capital B, it returns here small b and capital B. Similarly it returns a small b capital B here. Here is empty, it is of two sides, it means it returns small b capital B. Now here it is empty, here's it small b capital B, means it returns small b capital B. Similarly from 0, here so it return, so finally it means it returns simply a small b and capital B. So that is the longest substring here, which is of nice. So there is a simply code here. First of all, we write a base case of for here, and for the for the each step, for the each of operation, we simply generate a noted set here. And for the for we do the whole traversing of this string here, and simply store the in all the set here st.insert s of I. Okay, like simply traverse here, and we have to check if it's a smaller version. This tool over is nothing but to check the smaller version of s of I. So is it true, means a smaller version it's found in st, and also it's our upper version similarly is also found in st, means this is valid. So simply skip this part. And if it not true, so go to the next step. So that's why we make two splitting in the left part or right part, means this is I can say this is not valid. So there's a left part and there's a right part. So we simply call the main function here, and what we do passing here as dot substring 0 to I, means if I found the ith index character as my problem creating character here, so that's why I have to make a left string. So there's a, this is nothing but this is the starting index, and this is nothing but this is simply the length here. So the what is the length of the substring that is starting from the 0 index and at I minus 1 index. So it is of length of I, that's why I return 0 and I. Similarly for the right, so here I use as dot substring I plus 1. If I can remind you one thing, what if I in the substring function, if I pass only single characters, or I can pass a single parameter here, so what it means, it simply means it start from this index and end at the end of the string here. And now check if the left side is greater than right side, we simply return left, and the other condition is simply return right. And we see one thing here, like this is the string function, so we have to pass any kind of string here to avoid the any kind of error here. So simply return s, but we know very well it doesn't come to this, because it goes on this loop, goes on this loop. And if you have to pass to the base case, you simply return the empty string here. Okay, so this is the code for here. What's the time complexity for here? We simply first of all I use the set here, so that's why there's often. And this is of only length of 26, so I can say this is of one. So there's a this is and what is the recursive, this is the recursive stack I use, so that's why of, and due to this, this is auxiliary space here. And what's the time complexity? This is for the of and for the traversing of this whole string there. And at each operation we simply do of left, that takes of n, this takes of n, so basically this takes a whole of n, and so this whole takes of n square. So that's the of n square is the time complexity here. So this is the question.